Hi, in this lesson you're going to learn about a few types of angles that are used and referred to in trigonometry. Standard position angles is the starting place. Here's a definition and a diagram for standard position angles. Standard position angles are drawn from a place called an initial arm, which is on the x-axis, toward a place called the terminal arm, which is defined by a point P with coordinates of x and y that are a fixed distance, we call it r, from a fixed point. Let's call that O, or the origin. So think of a circle. Imagine this point P were able to move along this circle. It would be defining an angle theta. Now, positive angles occur when we rotate counterclockwise, so against the way that a clock arm normally moves. And a negative angle occurs when we rotate clockwise. And that's shown with this little arrowhead here. So this angle that's being drawn here is a positive angle because counterclockwise orientation. So that's an important starting place. Now also remember, because we'll refer to this often, that these are quadrants 1, 2, 3, and 4. Also, in standard position, 0 degrees is oriented at the positive x-axis, 90 at the positive y-axis, 180 degrees at the negative x-axis, 270 degrees at the negative y-axis, and 360 degrees at the same location as 0 degrees. Let's practice drawing some angles in standard position using these little diagrams here. First angle I'd like to draw is 150 degrees. So I'll do this one for you and you watch. We start from the initial arm being the positive x-axis. Because this is a positive angle, I'm going to rotate in a counterclockwise direction. I know that if I rotated this far, that's 90 degrees. I know that if I went all the way to the x-axis, it's 180, and I don't want to go that far, so I want to be about here. And I can draw a line segment or a little ray and put the point P here and say this theta referencing angle is 150 degrees in standard position. Now, the other thing I should do is put a little arrowhead here. There we go. So that's an angle in standard position of 150 degrees. It's in the second quadrant. You try this one. Negative 160 degrees. Pause the video and then rejoin once you've drawn it. Okay, your angle should look like this. It should be referenced to the initial arm, and this time going clockwise because of the negative, and almost to the 180 or the x-axis to the left side. All right, one more for you. I'd like you to draw 380 degrees in standard position, pause, and then rejoin. All right, now notice I rotated from the initial arm, the positive x-axis, counterclockwise, and I rotated all the way around, which is 360 degrees, and a little more. And that's where the point P is. Now, we don't need to pull out protractors and measure this accurately. It's just the fact that you've got it in the approximate place and you've labeled it is sufficient. All right, so that's what standard position means. Next, coterminal angles. Now, these are types of angles as well. Coterminal angles will have the same initial arm and the same terminal arm as another angle in standard position. Here's an example for you. If I gave you 30 degrees, 30 degrees may look like this. Positive, there's theta. So here's an angle that's coterminal to it. It would start at the same initial arm, it would have the same terminal arm, but I rotate further. This particular angle would be 390 degrees. Here's another example. Same terminal arm location, same initial arm. What if I rotated this way and stopped there? What would that angle be? Well, this angle would be negative 330 degrees. Negative because of the direction of rotation, and this little angle in here is 30 degrees, and we would go 360 for a full turn, so negative 330. Now, generally, here's how we calculate these. A coterminal angle, I'll use the symbol theta, and let's use C for coterminal, or COT, coterminal. What you do is you take the first angle that you're using and add 360 a certain number of times, where n is an integer. So if n were 0, the angle would be the same. If n were 1, I'm adding 360. If n were negative 1, I'm subtracting 360, and so on. There are an infinite number of coterminal angles for any given angle. Just keep adding or subtracting sets of 360. Another important angle to know about is called a reference angle. Now, a reference angle has a very specific definition. It is a positive acute angle. Not only that, it's measured to the nearest x-axis of a standard position angle. So, for example, if I gave you a position P, terminal arm in standard position, and I said theta is 100 degrees, then this right here is the reference angle. It is positive. I'm not going to worry about which direction I rotate. It's acute, less than 90, and it's the nearest x-axis. So the reference angle would be 80 degrees in this case. Okay, now you try this one. What if I gave you this point P, terminal arm, angle in standard position, and I said theta was 250. You write down the reference angle and then rejoin me. And I'm going to give you one more. I'm going to give you one right here, and I'm going to say that this one is, let's call that 320 degrees. Okay, pause the video, find the reference angles, rejoin me. Okay, here we go. So for this one, the reference angle is 70 degrees. I need to go back to this axis. Even though I'm going in this direction, it's going to be positive. Remember, it's always positive for a reference angle. And I want to subtract the 180 part to get the reference angle to be acute. In this case, I'm going to go all the way forward to 360 and then subtract the number I have. So a challenge for you is to generalize how do you calculate reference angles in quadrants 1, 2, 3, and 4. One more thing to show you at the end of this video. There's a symmetry pattern that's helpful to know. If I had a terminal arm and an angle theta in standard position, like that, and point P defined by x and y, well, there's going to be another possible terminal arm with the same acute angle and a point P. In this case, the y values are going to be the same because they're horizontally located from each other, same height, same y value. The x is going to be opposite signs because where this was moving to the right, this one's moving to the left. Likewise, in quadrant 3, there's going to be some point. This time it'll have coordinates negative x and negative y. And in quadrant 4, a positive x and negative y. So what we're recognizing is that the length of this portion, the x portion, is the same as this, and the length of this y portion up here is the same as this, this, and this. Okay? I could also mark these over here, I guess, like that, and like that. So we're going to just recognize a symmetry going on between these 4 quadrants that's going to benefit us in the future for discussions that we're about to have. Okay, so those are the very basic ideas of what's going on with standard position angles. There are a variety of questions you can be asked that relate to these, but if you know these definitions and refer to them, you should have no trouble working on problems with this.